Hi everyone and welcome to a new challenge. This is very complicated problem related to the inequalities. This problem is proposed by the professor Georege Apostolopoulos, which one of the greatest mathematician in the world in such a field, which is inequalities from Greece. The problem is prove that some cyclic CYC refers to cyclic and means that this value will be repeated frequently, so that the first term is sine A over root sine B plus sine C, and the second term will be sine B over sine root sine A plus sine C, plus, and the last value is sine C over root sine B plus sine A, as we will see later. This cyclic summation is less than or equal this value, and R capital refers to the circumcircle of the triangle ABC, and R small, it is the end circle of the triangle ABC. Let's begin our solution. Of course, this is our main problem. I will start with a very famous inequality which called Cauchy-Schwarz inequality. This is very famous, and it is a special case of Holder inequality. Holder, it is generalized, and when you put n with equal to, it will convert into Cauchy-Schwarz. So this is the formula of Cauchy-Schwarz, as you can see. And by the way, it is, as I mentioned, it is generalized. If you put instead of 2 here, you can put here P and here is Q, so that 1 over P plus 1 over Q equal 1. So you can make your own business by using this formula. Of course, we can square both sides. So I reached this level. So by making a comparison between this one and my problem, I will just try to apply Cauchy-Schwarz. So, as I mentioned, cyclic means that this value, as I explained before, and by applying Cauchy-Schwarz, this value, which is sine A, sine B, sine C in the numerator, represents xk, and the root in the denominator represents the yk. So I will just separate both of them and apply Cauchy-Schwarz inequality, as you can see. So this value is squared, and also this value is squared, and the root, we get rid of the root. So my main idea when I found Cauchy-Schwarz is to get rid of the root. This is the big issue that I had to deal with. So we will try to start from here. Of course, after making a common denominator, I reach this level. And from here, I will try to apply some small famous inequalities to help me to solve my solution. Of course, cyclic x minus y square, as I told you, this is x minus y square plus y minus z square plus x minus z square is greater than or equal 0. So after making expansion and simplify, I found x square plus y square plus z square is greater than xy plus yz plus xz. So this value is less than or equal sine square A, sine square B, sine square C. So if we add them together, it will be 4 sine square A plus sine square B plus sine square C. And also from the denominator, this is a very famous identity or inequality, that x plus y times y plus z times z plus x is greater than or equal 8xyz, and you can prove it easily by using AMGM inequality. So after applying both of them, I found that the numerator, as I mentioned, 4 times the bracket power 2, because we have also here sine square A plus sine square B plus sine square C. So when it multiplied by itself, so it will be squared, and the denominator is 8 sine A sine B sine C, and don't be confused, because when the this value is greater than, when it is reciprocal, it will be less than. So the direction is fixed to the right and nothing wrong with that. Okay, I will just multiply in the numerator and the denominator by sine A, sine B, sine C, and it will help me to find the equality of the my main problem. Of course, sine A, sine B, sine C, it is not fully explained here, but I can show you what will happen with this value. I will just stop my presentation and try to explain what will happen with this value. Of course, in my last video, I proved that fx equal sine x is concave when x belongs to from 0 to pi, and as a result, sine A plus sine B plus sine C will equal will be less than or equal 3 sine A plus B plus C over 3. This is from Jensen. This is Jensen inequality. And as a result, sine A plus sine B plus sine C, of course, sine 60 equal root 3 over 2. When I multiply by 3, it will be less than or equal 3 root 3 over 2. And also by using AMGM inequality, this value will greater than, I'm talking about this value, this is always positive value. So this value is greater than or equal 3 cubic root sine A, sine B, sine C. Okay, forget about the middle one. I don't need it. Let's focus on the first and the last one. 3 will be cancelled with 3, and by making cubic for both of sides, so sine A, sine B, sine C will be less than or equal root 3 power 3. It is the same, 3 root 3 over 8. So I will just substitute this one here. Okay, let's continue our slide presentation. We have very famous identity, combines the incircle and the circumcircle, which is 2r capital over r small equal sine A plus sine B plus sine C over sine A, sine B, sine C. And also I mentioned this in my last video, and we can apply the AMGM inequality, as you can see. And after simplifying, I found that 1 over sine A, sine B, sine C all squared is less than or equal 8 over 27 times r capital over r small all power 3. So when I apply this one and also the previous one in my main problem, if you remember, I will find my last solution. So after we apply both of them, of course, this is what I mentioned by Jensen inequality. And 1 over sine A, sine B, sine C all squared, this one will be less than this one in the next step. And all I have to do right now is to find the maximum value of sine squared A plus sine squared B plus sine squared C, as I mentioned. And of course, we can apply this famous identity. Sine squared A, it is 1 minus cosine 2A over 2 plus 1 minus cosine 2B over 2 plus sine squared C. So after I make some simplify, I reach this level, which is equivalent to this one. And sine squared A plus sine squared B plus sine squared C, after making more simplified, we reach this level. And of course, as you know, cosine lies between -1 and 1. And in all cases, it will be less than or equal to minus cosine square c plus cosine c. And equality holds when a equal b, and nothing wrong with that, because from the beginning I am focusing on the equilateral triangle, which I found the equality holds at it. And by making a perfect square, I reach this level. And again, it has nothing wrong with the equality of the equilateral triangle, because the angle C will equal 60 and cosine C equals half. So again, not everything is available to use. Some students could consider any perfect square applies. Be careful what you wish for, because you just need to apply the equality which you are focusing on, your target at the beginning, which already you calculated and found the equality on it. Sometimes it is in the isosceles triangle, sometimes it is in the right triangle, and the most cases at the equilateral triangle. So let's focus on our problem. Sine square a plus sine square b plus sine square c less than or equal 9 over 4. And by apply all of them together, I found this value. And don't forget to take the square root to reach my maximum value, which at the beginning of the problem. And this problem was not solved at the author's page until I solve it, and I propose it in his page and also in here in YouTube. And thank you so much, and follow the channel for more problems in the future, and thank you so much.